All right, so in the last video, we talked about exponential functions, a times b to the x power. And we referred to a couple cases where b was growth, so when b is greater than 1, or when b is decay, where b is greater than 0 but less than 1. All right, now we're going to talk about the rate at which it's increasing or the rate at which it is decreasing. So the value b is our growth factor. And the way that we can find out the rate of increase or growth rate is our b is equal to 1 plus the rate at which it's increasing. So this r represents our rate of increase or our growth rate. And our r is written as a decimal, and it's the percentage increase. So let's just say that b was equal to 1.15. And I wanted to find out what is the rate of increase. That would be 1 plus r, so we subtract 1 from each side. So that means our rate of increase is 0.15 or 15%. So when we have a growth factor, so when b is greater than 1, whatever it is above that 1 represents our rate at which it's increasing or our growth rate. And then the same thing holds true for our decay factor. So remember, our decay, if we know if it's exponential decay, it's when our b is less than 1 but greater than 0. So in this case, to find out what our growth decay is, it's b is equal to 1 plus r. And then when we subtract over 1 in this case, it'll tell us what our rate is. So let's just use 0.8 as is our b. So that is between 1 and 0. So 1 plus r. So when we subtract 1 over, our r is then equal to negative 0.2. So then we would say that our rate is a 20% decrease. So that negative just tells us that it is a decrease. So it tells us, so if we were to plug that back in to get to our b will be equal to 1 plus negative 0.2. All right, so you might hear a question say it's a decrease at 20% or you're losing something at 20%, and that just tells us that our r is then going to be equal to negative 0.2. All right, so we use this to help generate some of our problems. And we can use this idea here of b is equal to 1 plus r to help us come up with a different formula for our growth, for our exponential growth, which is just y is equal to a times b to the x power. We can come up with a more in-depth formula, and that's this here, where it, especially when we're talking about anything that we're finance, where we're trying to identify or we have a rate of change, and we're trying to see how much money we're investing, this is the formula that you'll use. All right, so our a sub t is the, so you'll also see this a sub t will be represented by p, but that tells us how much we have after we are investing something or after the percent change has already occurred. The a, so we have a sub t is equal to a. This a here is the initial amount or our starting amount. And then times 1 plus r, which we know is represented by b. And r is the rate of change. So if it's a decrease, then it'll be a negative. If it's an increase, it'll be a positive r. And then t represents the number of periods, number of time, or periods. All right, so this is the formula that we will use, and that we will use to solve some problems. And this is when it's a fixed percentage each time period. So that percentage will never change. So if you're investing in a bank that does at the end of every month, or at the end of every year, they will give you a percentage increase, and that percentage won't change each time. All right, so let's go ahead and do a problem. So it says you invested $1,000 in a savings account at the end of 6th grade. The account pays 5% annual interest. So this is something that in the future, it might not be annually, and it's something that you have to think about. But for right now, it pays annual interest. How much money will be in the account after 6 years? So let's write out our formula. A sub t is equal to a times 1 plus r raised to the t power. All right, remember our a, we'll highlight this in yellow, is our initial starting amount, which is we invested $1,000. So we know that this is going to be equal to 1,000 times. Now, it tells us that the account pays 5% annual interest. So since it's paying us that is an increase. So it'll be 1 plus 5% is equal to 0.05. So 1 plus 0.05, and it says 6 years, so that will be our t. So it's raised to the 6 years. All right, and then this a sub t, remember, this tells us how much we have after the investment, and that's what this is asking for. How much will be in the account after 6 years? And then we would just go ahead and plug this into a calculator. So then our a sub t is equal to 1,000 times 1.05 raised to the 6th power. So then we have a sub t is equal to 1,000 times approximately 1.34, and we times that by 1,000. So then the amount of money that you will have after 6 years is approximately, so let me erase this, let's say approximately, because we round it here, $1,340. So that's how much money you'll approximately have at the end of your investment after 6 years. All right, so for this problem, it's the exact same one that we just did. If you notice, it has the same percentage, 5%. 1,000 is being initially invested. The only difference is now they're saying how many years will it take to get at least 1,500. So in this case, we would have the exact same equation that we did before, where a sub t is equal to 1,000 times 1.05 raised to our x, or raised to our t. The only thing is now we don't know the t, so we're looking to see, well, when does this equal to 1,500? Right? How long will it take for us to get to that a sub t is equal to 1,500? So what we're going to do now is we're going to use a calculator to approximate this. In the future, we will be able to solve for this exactly, but now we're just going to use a calculator to approximate. And what we're going to do is we're going to plug this into our calculator. The only difference is, instead of a sub t, that will be going for y. All right, so let me start from the beginning. So we start at our menu. We can then go to press 7 for table. All right, first thing that we're going to do is we're going to set this table. So you want to make sure it starts at 0, and you should pick a fairly larger number. It usually goes from 1 to 5, but you want to make sure that you have a decent amount of x's being plugged in. So in case this could take 15 years, you want to make sure you have enough. So this 0 to 20 will be good enough for now. And then we plug in the equation where it's a sub t, which that represents y. So it's a sub t. So y is equal to 1,000. Now let's make sure that this is very particular. Make sure you press the times button. And then we put in parentheses 1.05. And then we raise it to the x value. Press execute. And now we go to our table. And this table, when we're at 0 years, we're at $1,000. When we're at 1 year, we're at $1,050. 2 years, a little over $1,100. So what we need to do is we need to scroll down in this table until this y value that we're highlighting is 1,500. So if you see, in year 9, it's 1,551. In year 8, it's 1,477. So that means at the end of year 8, we'll have $1,477. At the end of year 9, we will have $1,551. So since this money is going to be, interest is annually, at the end of the 9th year, we will get the $1,500. So this will be, the answer would be, at the end of the 9th year, you will get 1,500. All right, so that is your final answer for this question. It says it will take approximately 9 years. We will be able to use our calculators to solve for this x exactly. So we could say it's approximately 8.5 or what have you. But right now we're just using it to approximate. And that's it for this video.